Welcome to Statistics for Surveys, Session 1, Basics, Segment 1, What is Statistics? The objective of this segment is to get an understanding of what statistics actually is and what it does. We will be covering the following terms: statistics in itself, sample versus population, descriptive statistics versus inferential statistics, and finally mathematical statistics versus applied statistics. One question people always have had is how many? If you look, for example, at the Limbobo bone, which is dated roughly 37,000 years ago, you see that somebody was probably counting something. Now later, when states came into place, the state often also wanted to know how many. How many male, how many females in my country, how many people can work, how many animals do we have, etc. If you therefore look in old statistical dictionaries, for example the one from Mulhall from 1884, you will not find statistical terms being explained, but terms, for example, like able-bodied, that show the percentage of able-bodied people in, for example, England, which was apparently 23%. This is probably where the word statistics comes from. The state wanting to know something, and therefore statistics. It has the word state in it. States kept on collecting a lot of data, and it became more and more difficult to actually summarize that data. Here's an example of a relatively large data set. The first 36 people are actually shown, but this list goes on until roughly 2000. What's often done is convert therefore the data into, for example, a table. We can see the 972 people from this survey who are married. Another tool that can be used is to convert it into a diagram. This diagram shows the gender set out across how scientific they think accounting is. A third option that's sometimes used is the use of a statistical measurement. For example, we can see here that the mean, the average of the age of the respondents was roughly 48 years. To some extent, what we're doing here is we're trying to describe the data, hence the name descriptive statistics. The APA Dictionary of Statistics and Research Methods defines it like this: procedures for depicting the main aspects of sample data. I myself would actually summarize it or define it as describing data using tables, diagrams, and/or statistical measurements. Now, it used to be that people tried to actually get everybody that they were interested in and their data about them. Everybody you're interested in is known as the population. It's the complete set of objects of interest. If we visualize a population by circles, then each circle in this case could be either a person, it can be a car, it can even be a date. Now, nowadays we don't often take the entire population, but we only select a few people out of the population and create a so-called sample. A sample is part of the population. How you select these people is known as your sampling technique. It's the process of selecting from the population for your sample. Once you have a sample, it's possible to sometimes make statements about the population. This is known as making an inference. An inference is therefore a conclusion about the population based on a sample. It is quite important, though, that your sampling technique is good, so that the sample can actually represent the population. How you can use a good sampling technique and which ones are good and which ones aren't are outside the scope of this course. You can find plenty of material about this online. But it is important to remember that if the sampling technique isn't good, then also the inference will not be good. In this course we will assume that the sampling technique was always correct and therefore the inferences will also be. So descriptive statistics tries to describe data only, but inferential statistics therefore actually tries to make an inference based on a sample. So again, the APA Dictionary of Statistics and Research Methods has a rather long definition for this. I usually summarize it myself into that inferential statistics tries to say something about a population based on a sample from that population. We can actually now finally define statistics in itself. It has all to do with data, how you collect it, how you display it, and in the end, how you analyze it. As just now discussed, there's a big difference between descriptive statistics and inferential statistics, and statistics in itself is the combination of the two. As a last point in this segment, I'd like to address the issue of mathematical versus applied statistics. Now in this course, I'll be using mainly applied statistics. I will use the tools that have been proven by mathematical statistics and will actually explain how you can use them, what they actually do, but not because that's the focus of mathematical statistics, why they actually work. So the proof of the inferential techniques that they indeed can say something about the population based on the sample. That doesn't mean that in applied statistics we will not be doing any calculations. Sometimes by seeing how something is calculated, for example, you will actually also have a better understanding on what it is you're calculating. So we won't be proving any hardcore math statistical techniques, but we will be doing sometimes some calculations, but I'll help you out through those step by step.